So this is the work for the intro acid-base lesson. You've got some definitions. We've got salt, acid, base, and electrolyte. Those should be pretty easy. And then it's just one side of one page where you're going to have to do your dissociation reactions. I will send out an answer key, color-coded like I did here, so you know what they do. But basically, how to do the work. The definitions are in the notes. I'm not worried about that. For the compounds, all you have to do is figure out if they're acid, bases, salts, or covalent. And the way you do it is pretty simple. The acids are on table K. The bases are on table L. The salts are ionic, so metal, non-metal. And the covalent are going to be all non-metal. So non-metal, non-metal, or all non-metal, it doesn't really matter. Okay, now, for this worksheet, I'm assuming that everything dissolves in water. Okay, I didn't give you, the next issue would be, do the ionic ones dissolve, which you'd have to check table F, and then do the bases dissolve, the covalents dissolve, and then you'd have to do like dissolves like, and then believe it or not, some acids and bases aren't very soluble in water either. We're going to oversimplify and just assume everything dissolves to make life easy. So here's how it works. The acid, they give off H pluses. So when HCl dissolves in water, it gives off an H plus, and then what's left becomes a minus. And since they're dissolved in water, they both get an AQ symbol. Next one, sodium chloride, or the ionic compound. When you put it in water, it is going to dissolve into an A plus 1 and Cl minus 1. The reason I know it's plus 1 and minus 1 is because I know how to assign oxidation states. There's a rule for Na. You figure out that Cl is minus 1 to make the whole thing equal 0. You should know how to do that. NaOH. When I put that in water, there's another way to write this too. A lot of people, sometimes you may see it like this. You'll see H2O written in on top of the arrow. That's like a fancy way of saying put it in water, but you can write it or not. It doesn't really matter. That's going to break up into Na plus 1 and OH minus. The OH is considered a polyatomic. It is found on table E. It's minus 1. I could figure it out on my own, or I could just look it up from table E to get the charge, or just know that all bases give off OH minus, and then your life is simple. And then the next one, CH3OH. This one, technically it's actually a liquid, but honestly I don't really care. Nobody would, because it depends on the temperature too, so we're not worried about that. But at room temperature, it is a liquid. When you put it in water, well, it dissolves. So guess what it's going to do? It's going to stay together because it's covalent, and it's just going to get an AQ sign to say it dissolved in water. So notice there's no charge. It doesn't have, so there's no ions being formed. It doesn't break apart in any way. That's what covalent compounds do when they dissolve in water. And then as far as electrolyte and non, well, you know that these three are your electrolytes, so guess what? Again, just to mention it one last time, everything on this sheet is going to dissolve in water. I'm not going to overly complicate this by now trying to figure out which ones will dissolve and which ones don't, because believe it or not, even in all four categories, acid, base, salt, or ionic, sometimes they dissolve, sometimes they don't. And if they don't dissolve, they wouldn't do this. We're just going to assume everything dissolves for this to make it a little bit easier. So you're going to finish the rest of these, and then when you get to the very bottom, this is nothing special. It's just a different looking acid than what you're used to. If you look on table K, you can figure out how it breaks up. I'm going to let you do that. And then this one, I just went over in the notes for the last video of the two reactions of what this does when it both gains an H and when it reacts with water. That's why I have two lines, because I want to see the reaction when it just gains the H, and then I want to see the reaction when it reacts with water, and then you can fill in the rest.